Welcome back. Now we're using multiplexers to implement a function. We're in the practice number 7. So first of all, I'm going to explain the task description. The goal of this project is to design and implement a digital logic function using the multiplexers on the FPGA. So multiplexers are essential for effectively selecting between multiple input signals to produce a desired output, making them an ideal choice for implementing complex logic functions. So the project will leverage the Intel Max 10 FPGA to handle the interactive switching logic involved in multiplexer-based design, showcasing its effectiveness in high-speed digital operations. So I'm going to explain the development of the VHDL code. So the code represents a VHDL implementation of multiplexer function. So it takes 3 inputs. They are labeled by X, Y, and Z combinations, and them into selective line that controls the state of the 8 output signals. So we have D0 to D7, which represents inlets. Initially, all outputs are turned off by setting them to 0. The values of X and Y and also Z are concatenated to form a 3-bit select line that determines which output will be activated, based on the combination of these 3 inputs. A case statement is to light up a specific LED. So, as you can see, all the scenarios are set to 0 initially. So, all LEDs are turned off. But in the case which is how we will be behaving, this program in the FPGA are set in the following ones. So as you can see, some specific cases such as 001, 011, and 100 result in no LED being turned on, showing that not all combination of the inputs produce a corresponding output activation. Therefore, the code allows for selective control of the LEDs, depending on the values of the 3 input signals. So, for example, when the select line is set to 000 or X in 0, Y in 0, and Z in 0, there are the, the output signal set to 1. So similarly, other input combinations correspond to different LEDs being turned on or off, depending on the scenario. In this case, we are having these output signals because we have a truth table that corresponds to these signals, and that will help us to have the desired output signals for our specific design. So you will have to watch out what is your truth table. So you will have to turn on or off the output signals depending on your design. So I'm gonna jump to the physical part so you have a better comprehension of what we're doing here and you understand more about the truth table.
Welcome back. Now we are implementing this function of the multiplexer into the FPGA in the physical part. So as you can see, we have the LEDs over here and the switches. So in our truth table, if we apply 000, the output it will be 1. So as you can see, we have 1. Now, when we have 001, the output should be 0. So let's check this out. As you can see, it's 0. The next case is 010. So I'm gonna put 010. As you can see, we have the LED in on. Now, the next case is 011. So, as you can see, we have the LED. And then we have 100. this should be turned off. Then we have 1, 0, 1. This should be turned on, as you can see. Then we have 1, 1, 0. So as you can see, it's on. Then we have 1, 1, 1, and it's turned on. So I'm gonna show you the truth table. Also, we simulate this in the Quartus Prime. So I'm gonna show you the output. Here is the truth table. So it's working as we expected. See you in the next one.